This is problem number 3 on the sample test problems for test number 1. Solve each of the following equations algebraically. Part A, 2x minus 4, parentheses 5x plus 1, equals 3x plus 17. So this is a linear equation because all the powers on the x's are 1s, and all we need to do is distribute that 4 and then combine like terms, and then we'll solve for x. So distributing the 4, and then we'll combine terms on the left-hand side. And then I will move the x's to the right-hand side by adding 18x to both sides. And then we'll subtract the 17 from both sides, trying to get the x by itself. And then finally divide both sides by 21. Part B, k plus 3 times k plus 5 equals 20. If instead of a 20, this had just been 0, then this problem is much easier. K would equal -3 or -5. But because it's a 20, I don't see any shortcut. I believe that we need to FOIL on the left-hand side and then deal with it from there. So foiling on the left-hand side, we get k squared plus 8k plus 15 equals 20. This is a quadratic equation because of the squared. And generally, quadratic equations, you want them to equal 0. So let's bring the 20 over. And if we're lucky, we factor. You can spend a minute trying to factor that. I don't think it factors, which means our best bet is the quadratic formula. So normally the quadratic formula says x equals and then the negative b plus or minus all that. In this case, it's not x equals, it's k equals. Okay, so we start plugging these things in. We get -8 plus or minus square root of 8 squared minus 4 times 1 times -5, all divided by 2a, 2 times 1. Equals, let's see, so we've got a -8. Oops. We've got -8 plus or minus square root of 64, and then minus makes a plus 20, all divided by 2. -8 plus or minus the square root of 84 divided by 2. If you stop there, this is most of the credit. It's not full credit because it's not technically reduced all the way, but it's most of the credit. But if you want full credit, you got to go a little further with that 84 and recognize that 84 has a perfect square that goes into it. In this case, 84 is really 4 times 21. And that 4 is a perfect square, so it can come outside. So this equals -8 plus or minus the square root of. Let's see, so the 21 is in there, but the 4, which used to be inside, the square root of 4 is now a 2 on the outside. And then finally, we can clean this up at the end by recognizing that that 2 can go into both things on the top. That goes into 8 4 times and into 2 once. So then our final simplified full credit answer is -4 plus or minus the square root of 21. No need to write the 1 on the bottom anymore. Okay, so that's full credit. And this one here is most credit. Part C, 2t squared minus 10 equals 4. Again, it's a quadratic, but the technique is a little bit different. The quadratic we had to deal with up here was like a full quadratic. It had all the terms, including the k term in the middle. But you can see there's no t term in the middle, which means that what you can do is isolate the t squared. So let's add 10 to both sides. and divide by 2, trying to get that t squared by itself. And then finally, once the t squared is by itself, take the square root of both sides. And at that moment, when you take the square root of both sides, is when you need to remember that you got to put in that plus or minus. So plus or minus square root of 7, and we're done. Part D, x minus 7 to the 1/3 equals 5. So what does 1/3 really mean? It means cube root, and the opposite of taking the cube root of something is cubing the thing. So what we're going to do is we're going to cube both sides. I'll write the equation again. Both sides are going to get raised to the 3rd power. And the nice thing is on the left-hand side, the 1/3 power and the 3rd power cancel, and we just get x minus 7. And then 5 to the 3rd is 125. Add 7 to both sides, and we get our final answer, which is 132. Part E, 3a to the 2/5 equals 12. Just like in part C, the goal was to isolate the t squared, the thing with the power. Here the goal is to isolate a to the 2/5, again, the thing with the power. So let's divide both sides by 3. We get a to the 2/5 equals 4. I'm going to copy that equation again, and now we have to do the right thing to both sides. And the right thing to both sides is trying to get rid of that 2/5 power. We do that by raising both sides to the appropriate power. In this case, the power is 5/2, because that's the reciprocal of the 2/5. And the point is that that 2/5 and 5/2 will multiply and cancel. And if you think about it, it's actually the same thing that we did up above here when we took this 1/3 power and raised both sides to the 3rd. Okay, so on the left-hand side, we just get a. On the right-hand side, we get 4 to the 5/2, but let's see if we can find that without the calculator. Fraction power means radical. The 2 is the square root, and then the whole thing is to the 5th power. You can put it inside or outside. Hopefully you see it's a lot easier to put it outside if you have to do this thing by hand. So we've got square root of 4 is 2, still raised to the 5th power, and 2 to the 5th is 32. So a is 32. And it's actually really easy to stop there and call that your final answer. But we're actually missing something, and this is really subtle. When we raised both sides to the 5/2, 5/2 there and 5/2 there, we saw that really we ended up taking a square root. That's what the 2 meant in the 5/2, right? And if you take the square root of both sides of an equation, you have to put something in. And the thing you need to put in is a plus or minus. And so at that moment, when we took both sides and raised it to the 5/2, we really needed to put in a plus or minus. And so the final answer isn't just a equals 32, but rather a equals plus or minus 32. If you forget the plus or minus, you won't get full credit. You'll get almost all the credit. Like I said, this is a really, really subtle one right here. Finally, part F, 7 over x minus 5, all plus 2 equals x over x minus 5. Okay, my preferred technique for this kind of problem is to multiply all the terms by the lowest common denominator. So I'll copy everything again, leaving some space next to each term. And we're going to multiply all the terms by x minus 5. So multiply both sides of this equation by x minus 5. So I'll put an x minus 5 here, put an x minus 5 here, and then I'll put an x minus 5 over here. And this is a little different from on the previous problem where I said if you multiply the bottom by something, you better multiply the top by something. It's not what we're doing here. Here we're doing something different. You're multiplying both sides of an equation by x minus 5. You don't need to worry about doing the same thing top and bottom. You're doing the same thing left and right in some sense here. And the idea is that the x minus 5s from the denominators will all cancel. And so if you're careful, you can write down a much simpler equation. 7 plus 2x minus 5 equals x. And then we have to solve from here. So distribute that 2. Let's bring the x's to the left and combine the 7 and negative 10. And then finally multiply both sides by negative 1. And we get x equals 3.